Okay, ladies and gentlemen, this is Math, 6th grade, Engage New York, Lesson 7, Module 2. Today we're looking at the relationship between visual fraction models and equations. Now we need to learn a couple vocabulary words, probably you already know, but we need to review. The first one is multiplicative inverse, and then the second one is reciprocal. They actually mean the same thing, so you can sort of use them interchangeably. What this means is that, for example, we have 4 thirds times 3/4 equals 1. Now, 4 thirds and 3/4 become multiplicative inverses or reciprocals of each other because they, when multiplied, equal 1. So we could look at this as maybe 1/3 times 3, and essentially 3 is actually 3 over 1, and this would be the same, also equal 1, and that we know is now a multiplicative inverse or a reciprocal. Now you may see this written as A over B times B over A equals B over A times A over B. Really long sentence, all equaling 1. It's simply using the commutative property. We can put any one first, doesn't matter, but they're all going to equal 1. So let's get into So in our example number 1, we actually have 3/4 divided by 2/5. So the first thing we want to do is make our fraction bar, and that is on your sheet, and we are going to shade in 2/5. So there's my 2/5, all shaded in. Now the next question is, what part is actually our 3/4? So our 3/4 actually happens to be our 2/5 because that's the part that we're dividing. So I'm going to mark this in a new color, and this section is also 3/4. Now, what is the whole? Because that's going to be our end of question, really. So what is this whole piece we want to know? Well, let's take a look. Now, normally we would happily solve this, but we're going to take a couple extra steps, and let's take a look at this. If 2 units equals 3/4, we're dividing by 2/5, then 1 unit would be 1/2 of 3/4, and we are doing 1/2 of 3/4. That means that we are multiplying. So we can multiply that out happily, and we end up with 3/8. That means that each one of these boxes, as we have done before, equals 3/8. So now we want to know the value of all 5 units, and we know that we have to take 3/8 and multiply that by 5. So let's take that as 5 over 1. So 3 times 5 is 15. 8 over 1 would be 8. So this is going to equal 1 7/8 when we turn it from an improper fraction to a mixed fraction. So when we take 1 7/8, we knew was our answer from our last question, we still want to make sure that we got that same answer. Now remember, we did all multiplication on our first one. So let's try a look at this again. Again, here is our box. 1, 2, 3, 4, and 5 units. Now we are taking 3/4 and dividing it by 2/5. Now we have been doing this all the time and taking 3/4 and multiplying it by 5 over 2. So again, we got 15/8. But why does this 5 over 2 actually work? Why does this inverse work? Well, it works simply because of this. We are basically saying 3/4 divided by 2 times 5. The 2 came from that we were dividing it into 2 pieces right here. Now the 5 comes from this. We have the 5 pieces here. 1, 2, 3, 4, 5. So that's how we get that 5, and it comes all the way back down to here. But just like in the first section, we multiplied by 5 times to find the value of the total. We can do that here. So because we have this wonderful property in math that says we can do the order of operations anyway, as long as we don't have parentheses, that wonderful property says we can do it in any way. We can do it like this. So 3/4 divided by 2 is the same as saying times 1/2. Now that we can multiply that by 5 again. So let's look at this one. 1/2 times 5 equals 5 over 2. 3/4. We are right back to 15 over 8. So, but the question was, you might ask, how did I get from dividing by 2 to 1/2? Well, when we have something that looks like this, like our normal fraction, this wonderful bar, that division, that wonderful fraction line, right there, tells us that we're actually dividing 1 by 2. So when we have that division sign, making this fraction is the same. So we can do 3/4 times 1/2, or we can do it 3/4 divided by 2. But either way, we are saying this exact same information. Now, that sort of comes from the idea of that multiplicative inverse. If you remember, that multiplicative inverse said 4/3 times 3/4 equals 1. Well, in this particular case, 2 times 1/2 still equals 1, because 2 really is 2 over 1. But when we want to look at that division, we have that wonderful line right there that is telling us that we can actually divide. So what's happening is 2 is being divided by 2, which we know equals 1. So that's how that multiplicative inverse, or that reciprocal, works and why we use it so much. So you're going to go on and you're going to do your practice problems. We're going to do a couple more examples together as a class, and we're going to use some fraction bars. All right, y'all have a great day. Hope you took great notes.
Made with Doodlecast Pro.